A pleasant day to everyone. I am Lovely Daquiz from BSE 3B Mathematics and I will serve as your instructor for this video. On this video, I will be discussing Euler's theorem. But before we proceed, let us first identify who is the pioneer of this theorem. So from the name itself, Leonhard Euler was the pioneer of Euler's theorem. Leonhard Euler was one of the giants in 18th century mathematics because he was a prolific mathematician whose work spanned the fields of geometry, calculus, trigonometry, algebra, physics, lunar theory, and even astronomy. Furthermore, many of the notations that are used in mathematics today became popular due to Euler's effort. And some of this includes the function of x, sigma, the unit of imaginary number, the Greek letter which what we call pi that denotes the ratio of a circle's circumference to its diameter, and even the sine, cosine, tangent in trigonometric function, and many more. Leonhard Euler was also made contribution in the field of number theory, graph theory, logic, and applied mathematics. So much for that. Let us now proceed in our main topic, which is the Euler's theorem. In number theory, Euler's theorem states that if a and n are relatively prime, then a raised to p of n is equal or congruent to 1 modulo n. So there are four rules on Euler's theorem to verify that statement, and these are rule number 1, p minus 1 where p is a prime. Rule number 2, p raised to n minus p raised to n minus 1 where n is a prime power. And rule number 3, p of m times to the p of n. And for the rule number 4, n times the quantity of 1 minus 1 over p sub 1 times the quantity of 1 minus 1 over p sub 2 until to the quantity of 1 minus 1 over p sub k. So to let us much understand better, let's try to give some examples. So for our example, we have 11 raised to 109 modulo 21. In this case, we will try to use the rule number 4 of Euler's theorem, which is n multiplied to the quantity of 1 minus 1 over p sub 1 times to the quantity of 1 minus 1 over p sub 2. And in order to substitute the given value into the formula, we first have to get the totient function of our modulo 21. So for us to get the totient, we need to factor 21. And the prime factor of 21 are 3 and 7, which will be the p sub 1 and p sub 2 in our formula where n is the modulo 21. Now let's substitute 21 multiplied to the quantity of 1 minus 1 over 3 times to the quantity of 1 minus 1 over 7. Then let's calculate, and it will be 21 multiplied to the quantity of 3 over 3 minus 1 over 3 times to the quantity of 7 over 7 minus 1 over 7, and we will get 21 multiplied to the quantity of 2 over 3 times to the quantity of 6 over 7. Therefore, the value of our totient is equal to 12. Since we have the totient 12, we are now going to find the remainder of 11 raised to 109 modulo 21. So the equation will be 11 raised to 12 is congruent to 1 modulo 21. But before that, let us first divide totient 12 into our exponent, which is 109, and we will get 9.0833 and so on, which will help us to find the remainder of 11 raised to 109 modulo 21. So for our solution, it will be 11 raised to 12 raised to 9 times 11 raised to 1, since we have a remainder from 109 divided by 12, right? Okay, so 11 raised to 12 raised to 9 times 11 raised to 1 is congruent to 1 times 11, since 11 raised to 12 is congruent to 1. and 11 raised to 1 is equal to 11. So 1 times 11 is equal to 11 modulo 21, which the remainder of 11 raised to 109 modulo 21.